Hey, welcome to The Explainer. Today, we're diving into something that feels like it's been pulled straight out of a sci-fi movie. We're talking about AI that can actually evolve and improve itself. We're going to look at an open source project called OpenEvolve, which is built to discover brand new, better algorithms, pretty much all on its own. So let's just start with a really big question here. What if a computer program didn't just follow instructions, but could actually evolve? Try an idea, fail, learn from it, and then try something completely different, doing that thousands of times a second. What kind of impossible problems could a system like that solve? Well, that's exactly what we're about to find out. The secret sauce here is a concept called evolutionary coding. And honestly, it works a lot like you'd think. It's basically natural selection, but for computer code. Instead of creatures adapting to their environment, you have code adapting to solve a problem. Large language models, LLMs, are the engine here, constantly mutating the code to create new variations. And then another part of this system acts like the environment, deciding which code is the fittest and gets to survive to the next round. Okay, so let's get into the story of how OpenEvolve tackled its very first challenge. You can think of this as the origin story for our code-evolving hero. Every good hero needs a quest, right? For OpenEvolve, that quest was to solve a puzzle that seems really simple on the surface, but is actually fiendishly difficult to get perfect. This was the ultimate test to see if it could move beyond just obvious answers and find something genuinely new. And that puzzle is a classic in math and computer science. It's called circle packing. The idea behind it is super straightforward, but the number of ways you could solve it, well, it's astronomical. All right. Here's the mission. You get a square box and 26 circles. Your job is to fit all 26 of them inside that box. But here's the trick. You have to make them as large as you possibly can. Your score is just the sum of the radius of every single circle. So a bigger score means you've packed them in more efficiently. Sounds simple enough, right? And this isn't just about doing pretty good. There's a high score to beat. Google's original AlphaEvolve paper published a top score of 2.635. So that's our Mount Everest. That's the number our little open source AI has to try and hit. So how did our AI start out? Well, its first attempt was something you or I would probably try. It put a big circle right in the middle and then arranged the others in these neat, tidy rings around it. A totally logical first step. But the score was 1.87. That's nowhere near our target. It had a long way to go. But this is where the magic really starts. We aren't going in to fix the code. We're going to let the code fix itself. So let's just watch as it evolves over hundreds of generations. And you know what? The progress was almost immediate. By just the 10th generation, it had totally abandoned those simple rings for a much smarter hexagonal packing. That bumped its score up to 2.18. Then, by generation 100, it pivoted again to a totally different grid-based pattern, and the score climbed to 2.32. You could literally see it learning, but it still wasn't enough. And then it hit a wall. Progress just stalled. The AI got stuck, only making these tiny little improvements to its grid pattern. It was trapped. So to get to that target score, it couldn't just keep refining the same old ideas. It needed a breakthrough, a revolutionary leap. But how does an AI even have a eureka moment? This part right here, this is the climax of the story. This is the moment the AI stops thinking like someone just arranging shapes and starts thinking like a real mathematician. And this one line of code says it all. This was the leap. The AI didn't just move a circle, it completely rewrote its own strategy. It discovered a powerful math optimization library and a method called SLSQP. Now, in plain English, what it did was basically tell the computer, look, here are the rules, no circles can overlap, and they all have to stay in the box. Now, you figure out the single best placement using high-level math. This was a massive conceptual jump, and the result? A final score of 2.634. It almost perfectly matched the state-of-the-art score from a gigantic research lab. And it did it all with open source code and this incredible process of digital evolution. What a success. So we've seen what this thing can do, which is amazing. But how does it actually work?
let's pop the hood and take a look at the engine that's powering this whole evolutionary process.
At its heart, it's a four-step loop that just runs over and over again. First, the prompt sampler looks at past attempts that worked well. Second, a whole team of AIs gets those examples and generates a ton of brand new ideas. Third, an evaluator quickly tests all that new code to see how good it is. And finally, the best results get stored in a database, which feeds right back into step one. It's this constant cycle of create, test, improve, repeat.
And one of the key takeaways from the project was that it's not about having one single best AI. It's about using a whole team of them. You need some models that are super fast, like Gemini Flash, just to generate tons of ideas quickly. But you also need the more powerful, quality models, like Claude Sonnet, that can provide those deeper, more creative insights. That balance of speed and quality was absolutely crucial.
Okay, but you might be thinking, sure, it's great at packing circles, but is it just a one-trick pony? And the answer is a definite no. To prove that this system could actually generalize its learning, the team gave it a completely different kind of challenge. This time, the goal was to find the absolute lowest point in a really complex mathematical landscape. The AI started with the simplest strategy you can imagine, just randomly guessing points over and over. But through evolution, it independently rediscovered a classic, really powerful algorithm from computer science called simulated annealing. It actually taught itself core concepts like temperature and cooling rates, all on its own. This proves the system can learn fundamental principles, not just how to solve one specific puzzle. So when you pull back, you realize this is so much more than just a clever coding trick. It's an engine for discovery. It doesn't just solve problems we give it, it finds fundamentally new ways to solve them. And that leaves us with this final, really fascinating question. Now that AI can evolve its own solutions, what problems will it solve that we humans haven't even thought to ask yet? What breakthroughs are just waiting out there, in medicine or material science, for an AI to evolve the right question and then find the right answer?